here is another example of a related rates problem. So remember that the first step is always to read the problem very carefully and then draw a diagram that will help you. So at 4 p.m., a Tesla is 100 miles west of a Honda. So I might just start by just writing down what I'm reading here. Okay, and this is 100. Now, the Tesla is driving south at 95 miles per hour, so that looks like a rate to me. And the Honda is driving north at 65 miles per hour. So it looks like we have the Tesla driving south, and the Honda is driving north, and we're given 95 miles per hour for the Tesla. So the Tesla's driving faster than the Honda. How fast, okay, so this tips me off that we're looking for a derivative, is the distance between the cars changing at 8 p.m. At 8 p.m., let's suppose the Honda is here and the Tesla's here. This isn't exactly to scale. But the distance between those cars is going to be given by the length of this segment right here. So that's the diagram I have right now. And since the cars are driving directly north and south, I know that these are right angles and these are right triangles. Okay, so just a couple other things. I'm going to reread it again. At 4 p.m., the Tesla is 100 miles west of the Honda. We've got that. The Tesla is driving south at 95 miles per hour, and the Honda is driving north at 65 miles per hour. So I've got two rates here, and I'm looking for how fast the distance between the cars is changing at 8 p.m. So that's another way of saying, 4 hours have elapsed. So that is my first step. My second step is I want to just try to look at my diagram and write down, what are the changing quantities, like what quantities are changing with time, and give them some names. So I can see that this distance is fixed. They're always 100 miles horizontal distance, or this distance between them. Now the Tesla, I know the distance the Tesla travels, which would be this distance right here. I'm going to give that a, let's let x of t be equal to the distance the Tesla has traveled at time t. And we're going to similarly, we're going to let y of t, or you could just label it y if you want. And y of t is, and we're also going to need a variable to represent this distance. That's just the distance between the two cars. And so let me just call that z. So that entire distance here is z. The next step is I want to go back through the problem and I want to know which rates were given to me. Okay, and I said before these are rates and they were given. And what do those represent in our in our variables over here? Well, 95 miles per hour is the rate at which the Tesla is driving south. So that would be dx dt. And 65 miles per hour, well, that's the rate that the Honda is driving north. And so that would actually give me dy dt. So let's write those down. So this is step 3. We want to know the given rates. And we are given that dx dt, or you could use x prime if you want. X prime of t or x prime is equal to 95 miles per hour. And we are given that dy dt or you could write y prime of t, or you could just write y prime is equal to 65 miles per hour. And I don't believe we are given any more other rates, but we are asked how fast the distance between the cars is changing at 8 p.m. So we are asked to find, so the unknown derivative, remember rates and derivatives, rate unknown, rate is dz dt when 4 hours have passed, so at 8 p.m. Okay, so after we complete this step and we know what we're looking for, remember that the next step is I need to find a relationship between my quantities. Okay, so I have to figure out some way that these relationships x, y, and z are related. Now, if I look at my diagram here, I do see a triangle, and the minute I see a triangle, I always think of like the Pythagorean theorem. So I think, a squared plus b squared is equal to c squared, especially if it's a right triangle. And this is indeed a right triangle, and I see another triangle, right triangle here. The issue, though, is even though I know that this length is y, I actually really don't know this portion of the distance, and I don't really have any idea what this portion is. And as the cars move, these are always changing. And then not only do I have to contend with this triangle, but then with this triangle, I've got the same issue, is that although I know what x of t is, given t, I really don't know what this length or this length. So one thing I can try is I can try to look at the big triangle. So that's the triangle, the big right triangle that's made up of this whole side, and this whole side. And then I ask myself, it's still a right triangle, and the question is, do I have some way to represent this side, and this side, and this side? So in this case, let's take a look at that. So this side I know is the same as x of t. So this side of the triangle is just y plus x, y of t plus x of t. This side we actually know is 100, right? So that's kind of nice. And then this side over here is represented by the variable z. So that actually does give me a relationship. If I use the Pythagorean theorem, it will give me a relationship between these, the three sides of this right triangle. Okay, so let's write that down for our step number 4. So we're going to find a relationship between our quantities that are changing, so between x, y, and z. And as I said above, the relationship was, we looked at the big triangle and we saw that this side was x plus y, this side was z, and this side stayed 100. So the relationship is Pythagorean theorem. Okay, we have that z squared is equal to x plus y squared plus 100 squared. Okay, and that is a relationship that relates the three changing quantities. So our next step is we are going to take the derivative with respect to t. So in step 5, we're going to differentiate both sides of the equation with respect to time. And I'm going to use the shorthand to do that. So remember, I'm differentiating with respect to t, and therefore I'm going to have to use implicit differentiation and the chain rule as well. The derivative of z squared with respect to t is 2 times z prime. That's the chain rule. And the derivative of this expression, again, I'm going to have to use the chain rule, x plus y times the derivative of the inside, which is x prime plus y prime. And then this is plus 0. So I'm canceling, I'm dividing both sides by 2. And since we are, I'm just going to solve for z prime. because that's our unknown that we're looking for. And I get x plus y times x prime plus y prime over z. So now that we have an expression for our unknown z prime, in order to solve for the unknown z prime, we just have to fill in all of the quantities here. So we know that x prime is 95 miles per hour. We know that y prime is 65 miles per hour, but we need to find z, x, and y, and these are the distances traveled after 4 hours. So let's just go back to the original diagram. And if we look here, what we're actually looking for x, y, and z is we are looking for, we need to know what is y of 4 and what is x of 4. Y of 4, okay, would be 65 miles per hour times 4. So that would give me 260 miles. And x of 4, how far did the Tesla travel? Well, that would be 4 times 95. Well, that would be 380 miles. We know that this side of the triangle is 100 miles. So now I know the big side here is going to be the sum of 260 and 380. So that gives me 640. So now we actually have enough to use the Pythagorean theorem, because we know that the hypotenuse squared is equal to the length of this side squared plus the length of this side squared. So let's just write that out. So we know that z squared is equal to 100 squared plus 260 plus 380 squared. And we know that, therefore, z is equal to 100 squared plus 640 squared. Square root. Okay, and that is approximately 647.77. Okay. So the point is we have found an expression for z and an expression for y, an expression for x, so we can finish the problem. So going back to this step, z prime, so x plus y, x was 380, y was 260, and then x prime was 95, plus y prime was 65, and we divided by z, and the expression we found for z was 100 squared plus 640 squared. And if you punch that into your calculator, you get 158.081 ... So I'm just going to round that to 158.1 miles per hour. Okay, so the distance between the cars is changing at a rate of 158.1 miles per hour at 8 p.m.